Okay. So trimmed mean. In some of the questions, okay, so we've done mean, median, mode. So let's talk about what trimmed mean. So trimmed mean can be a better calculation, more representative. The reason why is sometimes we have outliers that are affecting our data. It's skewing our data is what we say. It's a skewed answer because you have one or maybe two or three numbers that are not like every other number. They're different. They're way out there. But they affect the average because we're adding them in and we're including them. And so what we can do is we can trim those numbers off. We can find a new average not including those outliers. Okay? So the mean calculated, so a trim mean is the mean calculated by disregarding an equal number of data points on both ends of the range. So often we'll exclude the largest and the smallest number when we find trim mean. Okay? So let's look at, they have an example here, but we're going to actually jump and do our own example. Really quickly, you can see they found the mean, but then if we want to trim it, which one of these numbers is an outlier? For sure. 20. Yeah, 20 is obviously an outlier. Okay? But usually we like to take one from the top, one from the bottom. Eric, are you with us? Put that away, thanks. Okay? So we're going to take away 20 and 3 and find a new average with the other numbers, not including 20 and 3. And that will give a better picture of the new average. Okay? So let's actually try this ourselves. So here's on page 124. We're going to find the arithmetic mean. So arithmetic mean is just the usual mean that you're used to. And the symbol for mean is an X with a bar. Okay, I'll make this larger. Maybe it'll be easier to read. There you go. Okay, so arithmetic mean, how do we find the mean of a number, of a set of numbers? Add them all together and then divide by how many there are. Okay, so let's add them up. Grab your calculators. If you want, you don't have to write this all out. You can go straight to just adding them together if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. Okay? So grab your calculators. Come on. There we go. Okay, so let's add these together. We have 125, 164, 183, 54, 132 plus. Okay, a common mistake that I see students do is they type this all in, which is good. That's okay. But then they do this, divided by 10. Okay, what's wrong with this? You gotta let the calculators doing thing, meaning what? Add them and then divide by 10. So can I type in divide by 10 here? No, because the calculator does BEDMAS. It's not that smart. It can be if you it doesn't know what you're thinking. You have to tell it what you're thinking. We want to add these up and then divide by 10. But BEDMAS, with this? BEDMAS would be just dividing these two numbers and then adding. It won't add all the numbers together and then divide. So you want to just add them together. So delete this, delete that, get our sum. Our sum is 2,185. Divide by 10 is 218.5. So then we divide by 10. Did you get the same sum? Yes? Yeah? Okay, good. Okay, so let's, what outliers are there in this data? What are our outliers? Are there any outliers here? Yeah, which ones? 476 and 524. Are there any other ones? Or are the other ones pretty close together? Okay. So in this is an example where our outliers are just the two pieces of data that are way out there. Are there any on the other end, the low spectrum, that are outliers? You could use 125, but is it close to other data? Yeah, 132 and 133. So you could, when you do trimmed mean, there's often a little bit of discrepancy. There's more than one answer because someone might feel like 125 is an outlier. We could calculate it without 125. But the next person might feel, actually, that's pretty close, so I'm going to leave it in. Sometimes there's more than one answer for trimmed mean because it depends on what you feel is the outlier, right? Normally, they stand out. 476, 524, they stand out. They are the oddballs in the group, and they usually will. So let's find our new trimmed mean. So trimmed mean is not so bad. All we're going to do is exclude those two numbers. So we're going to add everyone else together. And now, how many are we going to have? How many pieces of data are we going to add together if we take off those two? 8. So we'll divide by 8. Now, one thing you could do instead of adding them all together is we have our total up here. We could just subtract off those two numbers. That's what you did. Yeah, and that's a lot faster. So instead of adding all these numbers together, 154, 132, 129, 470, so 165, and 133 divided by 8. Okay. Now, if you have one of these calculators, it wouldn't be that hard because you could go second enter twice and then go back and delete. Delete, 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 delete. Okay, so that would work to get your new sum. Another way you could get your sum is, like we said before, take your old sum of 2,185 and let's subtract off the two outliers, 524 and 476. That also gives me 1,185. Might be a lot quicker. Then divide by 8. Our trim mean is 148. So about 148, 125. Okay, which one do you think is more accurate? The trimmed or the original? So, depends on your application, right? If you want the average of all the numbers, then of course the first is going to be better. But if you want more of a representative of most of your data, then trim mean is actually way more accurate. Okay, guys, I want to see cell phones put away and not out. In your pockets, not turned on, not in your ears, okay? Let's just get through this lesson together. Okay, so trim mean is often more accurate. All right, let's look at the next one. Can you please find the average, the mean? Go ahead and find the mean. For 7 days. So negative 6.6, yeah, 57 degrees Celsius. Okay? So it means pretty easy to find. On what day did the Chinook occur? Chinook. Do you know what a Chinook is? Yes. No? They happen in Calgary. We don't really get them in Edmonton, but in Calgary they happen all the time, right? It's like this, because of the way the mountains are, they can get basically a really warm day all of a sudden, right? It's pretty awesome for just the warm air comes over the mountains. It's pretty awesome. Has to do with, and the ocean currents too in the mountains. I don't know. Anyways, so Chinook is that warm air that comes in all of a sudden in the middle, like it's just a really warm day. It's pretty awesome. We don't get them really. Sucks. I know. So which day did the Chinook occur? Wednesday. Yeah, 15 degrees Celsius is the outlier. Okay, so our trimmed mean, how are we going to find our trimmed mean? Take the 15 off. Now be very careful, because when we take 15 off of the negative 46, what's our new sum? Negative 61. Okay, our new sum over how many days now? Over 6 days, because we're going to exclude that. So when we take off the 15, either subtract 15 from this. We get negative, so our new sum is going to be negative 61. Divide by 6. Negative 10.1. 16, okay, 10.2 degrees Celsius. Do you see the difference in averages? How that one day skewed the data enormously. So is this a rare occurrence? So the average would be more realistic for the average for that time of year would be more realistic of negative 10.2. Okay? The 15 was a rare occurrence. That's our trim mean. So what's a better indicator of expected daily high in Calgary? The trimmed, right? Because a Chinook is a rare occurrence. It's not an average day type of thing. So the trimmed mean is going to be a better indication. Okay, do we understand trim mean? Yeah, makes sense? Exclude the outliers, find your mean. Not very hard. Okay, so let's skip the next one. Okay, number 3. Because do we get trim mean? Are we okay with trim mean? Yes. Okay, so let's skip this 3 and let's go on to weighted mean. So weighted mean is more realistic of what you see at school, right? Are your tests and quizzes weighted the same? No, which can be a good thing, could be a bad thing. They're not weighted the same. Your final exam is weighted differently than, say, a unit test. So how is your final mark calculated? That's what we're basically going to work on today, is weighted mean. Trim mean is pretty simple. Weighted mean is a little bit more difficult. So weighted mean is when different values are weighted differently. And we get that because you're in school and you see that on your report cards, right? Different things are weighted differently. So this is an example that they already did. We're going to work through our own example. Let's go over to number 4 here. So it's a lot, when we find weighted mean, it's really helpful to make a chart. Okay? So Karina, I think that's how you should say her name, Karina, is calculating her final grade in Spanish class. Yay. Hey, I don't know Spanish. Yeah. You know Spanish? Nice. I tried to take it once. I went to Italy and it helped for a couple words. And anyways, in the course, assignments are worth 15%. Okay? All together, that's important. So 15% all together are your assignments. Quizzes are each worth 5%. Presentation is worth 25, and the final is worth 45. Okay? So what we're going to do is I want you to all draw this out. We're actually going to make a chart. There's no room? There's a little, I did it. There's a little room. You can do it. You can fit it in. Okay, just write semi-small. So we have our category. We have the weight. The mark. Yeah, we're on page 126 at the bottom. Your mark. And then your weight times your mark. So there's 4 columns. Okay, so it says that altogether the assignments are worth 15%. So the assignments are one category. And their weight is worth 15%. Okay, now your mark on your assignments. How are we going to figure out the mark on the assignments if it's all together? We're going to have to average them. Okay, so 8 out of 10, what percent is 8 out of 10? 80%, good. What percent is 6.5 out of 10? 65. And what percent is 16 out of 20? Reduces to 8 out of 10. So 80. Okay. So what's the average she got on her assignments? How would we find the average on her assignments? Add them and then divide by 3, because there's 3 of them we're adding together. We want to average those 3. So what's her average on her assignments? 80 plus 80 plus 65. And then divide by 3. So 225 over 3 gives you 75%. So altogether, her assignment, she got a mark of 75% average. Okay? So what we want to do now is it's weighted 15% of her final mark, and she got 75. So we're going to actually end up multiplying the weight times the mark. 75 times 15. What is 75 times 15? Because it's weighted 50. We only want 15% of it. 1,125. Okay. Okay, next it said that each quiz is worth 5%. How many quizzes did she write? 3? Okay, so we have quiz 1, quiz 2, because they're each separately worth 5%. Quiz 3. So their weights are each 5%. They each have their own weighting. They're not all together. They're separately worth 5%. So you can't put them together and make them 15. It won't give you the same thing. Okay? So one of them, what was the percentage on her first quiz? 10 out of 10. 100. Hundo. I like saying hundo. Okay, 7 out of 10. What percentage is that? 70. 70%. And her third quiz, 7 out of 10. 70. Okay, so quiz 1, 5% times 100. What does that equal? 5 times 100. 500. 5 times 70. 350. And 5 times 70 again would also be 350. Okay. Now, she has a presentation. How much is the presentation worth? Presentations are worth 25%. It says up at the very top what the weightings are, right? Her presentation's worth 25. How much did she get on her presentation? Her mark? 85 out of 100, so 85%. 25 times 85 is? Jordan? 85 times 25? Come on, where's your calculator? You should be grabbing one then, signing it out. Tell me what 85 times 25 is. 1,700?
2,000.
Oh, 2,125? Okay, last year has a final exam. Okay, what's the final worth? 45%. Okay, her mark was what on her final? 86. So 45 times 86. You get 3,870? Yeah? Okay, so last, your totals. Now, the weighting should always equal 100%. Does 15 plus 5 plus 5 plus 5 plus 25 plus 45 add to 100? 40, 50, 60, 70, and then 30 and 30, that's 100%. Oops. So our weighting here is 100. That's good, right? That's 100% of our mark. We don't want to have anything missing. Now, what we want to do, does it make sense to total up her marks? No. But we are going to total up her weight times mark. Okay, so this is going to be out of how much the total marks she earned. So let's add those together. So we get a total. We want to add those all together. So this total gives us, add them all together. Okay, what did you get? Perfect. Okay, so now we're almost there. We almost have her mark. So 8,320, so is going to be her grade out of So to get her mark, we take the 8,000, their weight times mark over the weight of 100%. So we just have to divide that number by 100 and we have our answer. So her grade, her final grade, the 8,320 divided by the 100 gives us 83.2. So that's her final mark. That's how we calculate her weighted grade. So the easiest way to do this is always going to be a chart. It's a pain in the butt, I know. So much work, I know. Hey? No, we're not. We have one more, couple more exams. I know, it's a long day, I told you. Okay, but maybe we'll do, we're going to try an activity. We'll take a break, okay? So, there's still